So today we're gonna see the sketch note for sets. So this is the part 1 of the sets sketch note. So first, what is sets? It is a collection of well-defined objects. Then in a set we cannot repeat an element. Then as first we have to go how we are going to represent the set. The representation of sets can be done by three methods. One is set builder form, another is roster form, and Venn diagram. In set builder form, it is a statement which defines the elements in a set. So we can example, if a is equal to x such that x belongs to n, which is a natural number, that is 1 greater than x lesser than 5. And in
1 greater than x. 1 is less than x.
1 is less than x and greater than 5.
X is less than 5.
Less than 5.
மறுபடியும் சொல்லு.
1 is less than x greater than 5.
1 is less than x. X is less than 5.
1 is less than x and x is less than 5.
அது இப்படியும் சொல்லலாம். X lies between 1 and 5.
That is, okay. X lies between 1 and 5. So in roster form, we just write the elements which is in a set. For example, 1, 2, 3. And the Venn diagram is the representation of the sets. Like for the operations of sets, we use this Venn diagrams. For example, A intersection B, we will discuss about this later in the 5th step. And if we, for example, 2 circle, which is A, B, and this whole box is represented as universal set. We'll learn about it in types of sets. So intersection represents for the common point. So we can shade the common value such that this is the Venn diagram for this example. As the next steps, let's see the types of sets. Types of sets, we have around 7 types of sets. First is empty set. An empty set is a set which does not contain any element in it. And equal set. If, for example, there is a 2 set, that is set A and set B, which both the values are equal. For example, set A is equal to 1, 2, 3 and set B is equal to 3, 2, 1. It may be rearranged, but both are equal. Then universal set is all type of like basic set of all numbers. For example, natural number, real numbers, irrational number, rational number, everything which comes under in a set is a universal set. Then singleton set is in a set where when one single element is present, it is a singleton set. Finite and infinite set. In finite sets, definite number of elements will be present. For example, A is equal to 1, 2, 3. That is, it has only 3 elements. So that is a definite set. Infinite set is an infinite number of elements it contains. For example, A belongs to n, natural number, that is 1, 2, 3, it goes on. Then power set. Power set is a collection of subsets. It's a collection of subsets. The formula for power set is P of A is equal to 2 power n. Then subset. Subset is for example, A is a subset of B means the elements which is in A should also be in B. So such that lowercase a belongs to A as well as B. So that is a subset. This subset can be defined as 2 another subsets also. One is proper subset and another is superset. If A is a subset of B, then A is not equal to B, where this A is a proper subset and this B is a superset of A. Superset of A. Then next we go to intervals. Intervals which we will later study in relation and functions, but we have an introduction of this in our sets chapter. So intervals can be represented by 2 types. One is open interval, like which this parenthesis and the closed interval, which is a square brackets. This can be applied for real numbers. Then operations we are going to use for the sets. Operation we are going to use for the sets is union, intersection, difference, complement. This A union B means we will later discuss about this in the properties of the sets. This about union, intersection, difference and complement.
Good, very good. Super.